Hello everyone, welcome to my first lecture on electrical measurement and control. So before starting, here are two books of my personal recommendations. These books are very detailed in nature. First is Electrical and Electronic Measurement and Instrumentation by A.K. Shahani to cover the electrical measurement part of the syllabus, and second one is Automated Control System by B.C. Kuo to cover the control system part of the syllabus. Today we'll start with our first unit of the syllabus, that is transducers. So what is transducer? To put it simply, a transducer is a device that converts a signal from one form of energy to another form. For example, microphone, which converts sound energy to electrical energy, loudspeaker, which converts electrical energy to sound energy, antenna, which converts electrical energy to electromagnetic energy, etc. I've seen students getting confused between sensors and transducers, so let's clarify that confusion. So a sensor is a device which responds to physical stimulus, and a transducer is a device which converts one form of energy to another. So a constant alloy wire is a sensor, but if we attach appropriate electrodes and input-output mechanism to that alloy, it works as transducer. So what is constant? It is an alloy made of 55% nickel and 45% copper. Below you can see the wire on the left side and strain sensor made of the wire on the right side. So if transducer convert one form of energy to another, then what would electrical transducer do? It would convert one other form of energy to equivalent electrical energy. Transducer or measurement systems are not perfect systems. As an engineer, you must know the capability and shortcomings of a transducer to properly assess its performance. There are a number of performance-related parameters of a transducer. These parameters are called transducer specifications. Transducer specifications inform the user about deviation from the ideal behavior of the transducer, following are the various specifications of a transducer system. Sensitivity. So more sensitive the transducer will be, the more it can detect the minute changes and convert it to another energy. Operating range. The transducer should have a good range of operation. Cross sensitivity. Suppose we have to measure strain. Now strain can be measured with the variation of resistance of the strain gauge, which in turn vary the voltage. So this is called cross sensitivity. Errors. So we have to select transducer with minimum amount of error, because practically nothing is error free. So when the factor that is being measured is converted to another form of energy, there must be error, and when denoting that equivalent energy, we have to keep in mind the amount of error that transducer contains. Operating principle. Transducer is selected on the basis of operating principle. For example, some work on the variation of resistance, some inductance, some capacitance, etc. Transient and frequency response. There are factors like peak overshoot, rise time, which are fixed and cannot be changed, so we have to select the right transducers that meets the desired properties. Loading effects. The transducer should have a high input impedance and low output impedance to avoid loading effects. Environmental compatibility. Input-output relation of the transducer should be maintained under specific environmental conditions. The transducer must not break down. Insensitivity to unwanted signals. The transducer should be able to ignore the unwanted signal, that is the input, so that it does not get converted to unwanted output. Transducers can be classified as analog and digital transducers, primary and secondary transducers, active and passive transducers. There are other type of devices which convert electrical signals to other form of energy, which are called inverse transducers. Analog signals are those which converts input signals to continuous output signals. Example are thermistor, strain gauge, etc. We'll talk about these transducers later. Digital signals are those which converts input signal to discrete or output or pulse output. Okay, so Primary transducers are those, as mentioned here, which convert other energy signals directly into electrical signals. Secondary transducers are those where a middle step exists between energy signal to electrical signal conversion. On the basis of transduction principle, transducer can be divided into resistive transducer, capacitive transducer, inductive transducer, voltage and current generating transducers, etc. Active transducers. Active transducers are those that generate the electrical output without the aid of external devices. For example, a solar cell. You only need the solar cell to convert light energy to electricity. Passive transducers are those which generate electrical output with the help of external aid, like, for example, strain gauge. In a strain gauge, when strain is applied, it changes the resistance of the wire, but it does not produce any electricity. And we need external power supply to convert that change in resistance to change in voltage. So that's it for today, guys. See you next time. Thank you.